This is the
This is the
third
third
lecture of
lecture of
the
the
climate change
climate change
webinar
webinar
series
series
on the
on the
theme net
theme
zero
net zero
emission
emission
pathways.
pathways. Am I clear now?
Yes, sir.
Hello?
Yes, sir.
Okay,
Yes,
thank
sir.
you. Thank you. So, incidentally, today is also the Net Zero Emission Day. It's good that we are having this webinar today on
Your voice is not audible, sir. Sir, unmute yourself.
another person. Okay. Am I audible to you? Hello? அந்த வாய்ஸ் clear இருக்கா? Some other system.
Now clear, sir.
Can you hear me now?
Yes, sir.
The third webinar we are having today on and I was saying that our lifestyle has today totally to a very healthy lifestyle, and we are very conscious about our food, having a healthy food habit, hygienic. We have suddenly become more conscious about hygienic way of day-to-day living. Uh, Very soon we'll also need to realize that we need to also adopt a healthy, low carbon lifestyle. So that's going to be a mandate and a very, and it's going to be the need of the day in future very soon. India, as a country, has committed the Paris Agreement to go for an emission reduction of 33 to 35%, and also to cut its fossil fuel power generation and switch over to renewable power to about 40% of its power generated by 2030. So it is high time that the states, in alignment with the country's national policy, should uh, plan their carbon footprints and emission pathways to reduce the carbon dioxide emission from the various sectors. So with this requirement, we had thought of having this webinar on net zero emission today. And we have three eminent speakers with us. Dr. G. Renuga Devi from Manakala Venagar Institute of Technology at Puducherry, Mr. Will Hall, who is Associate Fellow at Terry, and Mr. Mohammed Subhan Khan, who is Research Associate at Terry. So the first session will be handled by Dr. G. Renuga Devi, uh, who holds a PhD degree in electrical engineering, and she has over 15 years of experience in research and academic activities, and she has published 20 referred international journals, 15 publications in national and international conference. Her areas of interest are renewable energy, smart grid and microgrid, electrical drives and control systems. I welcome Dr. G. Renuga Devi to give her uh, speech now.
Thank you, sir. Thank you for giving this opportunity. So, very good morning to all. So, we hope that all are safe and healthy. Okay. So, shall I start my presentation, sir?
Yes, ma'am. Proceed.
So, all of you pin my screen. Renuka Devi, your presentation. So, all of you pin that screen. Sir, PPT is visible.
No, madam, it is not.
Sir, PPT is visible. Okay. So I'm going to address about these. We have to reduce the carbon dioxide emission by using renewable energy sources. So I have to address about what is meant by carbon footprint, how to mitigate the carbon footprint, what is the pathway for carbon footprint with the help of renewable energy sources. We have to see one by one. So these are the outlines. First, we have to say about the introduction section. Then we move on into zero emission day, carbon footprint. So what are these roles for renewable energy sources for carbon footprint? Next, we go for the applications by using solar DC lightings. We have to reduce the carbon footprint maximum by using LED lights. So different ways of reducing carbon footprint other than lighting sources. So, before entering into this detailed session, we have to discuss about what is meant by climate change. So, the climate change is the change in the changes happening in the average conditions. See, the Earth average temperature has been increasing much more quickly than they would expect over the past 150 years. With the today we are facing these issues with due to uh, maximum climate change we are facing now. So what are the issues we are facing today? Rising sea level, shrinking mountain glaciers, ice melting at a faster rate, and also we are facing changes in the flower and plant blooming times. See, there are a lot of factors that contribute to Earth climate. However, the scientists agree that Earth has been getting warmer in the past 50 to 100 years due to human activities. Human activities. So, what are the human activities? We have to burning fuel to power factories, cars, and the buses are changing the natural greenhouses. These changes cause the atmosphere to trap more heat than it is used to. So, it leads to warmer the earth. So, what are the greenhouse gases we have to getting in our atmosphere here? Carbon dioxide, methane, nitrous oxide, hydrofluorocarbon, perfluorocarbons, sulfur hexafluoride. From these, carbon play a major role so in the climate change. So we only focus on the carbon dioxide, how to mitigate these carbon dioxide emissions. These are the human activity produce the carbon dioxide emissions. So electricity generation, transportation, industry sector, agriculture sector, commercial sector, and the residential sectors plays major roles for carbon dioxide emission. See here. So this is in carbon dioxide emission in teragrams. Tera means 10 power 12. See which one plays major contribution for carbon dioxide emission? Electricity generation. Today we are using the conventional sources, fossil fuel based after attending this webinar, all of my try to use the bicycles and switch off the light loads when not in used. Okay. What are the simple rules they have to mention in these zero emission days? Don't use burn oil, gas, or coal. Already Saris mentioned. So zero emission day rules are. So we have to minimize or eliminate use of electricity generated by fossil fuels, and also don't put any in harm way. See, all the essential and emergency services operate as usual. So we have to concentrate these two on. Don't use burn oil, gas, or coal, and also we have to minimize the electricity by using fossil fuels. Okay. So where does we get carbon dioxide? So usually carbon dioxide measured in terms of ppm, parts per million. So what is the important for that? See, carbon dioxide is a greenhouse gas. We have to know that. So too much carbon dioxide in the air makes the earth get warmer and warmer. What happens? Automatically sea level increases. So ice melting at a faster rate. So rainfall pattern changes. So due to this carbon dioxide, when human burn fossil fuel like gasoline and coal, carbon dioxide produced. So see here, the carbon dioxide is at 412 parts per million. The 412 number represents the 1 million particles of air. There are 412 particles of carbon dioxide. But many scientists think that we have to reduce that ppm level 350. So 350 ppm is a much healthier number, and we should try to reduce our use of fossil fuel to get the number back. See here, years before today we are below the 350 ppm. Now we are at current 412 ppm. So where does the carbon dioxide we have to receive this? So by burning petrol, diesel in our car, van, generators, and also electricity generated from fossil fuel power station, coal, oil, and gas in our power station. Virtually all human activities cause carbon dioxide emission that lead to climate change. So that every person, the society is responsible for these carbon dioxide emissions. With an increasing expected energy demand in India is increasing day by day. So India play a major role in global carbon policies and future low carbon transformation. In 2015, India emitted only 1,869 megaton carbon dioxide. From that, 15% we have to from power and heat generation. So at present, CEA projects estimated carbon dioxide emission in the year 2021 to 2022 is 983 million tons. When we move on into 2026 to 2027, it further increases 1,165 million tons. So India submitted the INDC on 1st October 2015. The national level for India, it implies three key goals to achieve this agreement, Paris Agreement. So what are the major key rules is to reduce the emission per gross domestic product output by 33% to 35% by 2030 from 2005 levels. See, what is our 2005 level? Anyone guess it? What is our emission product in the 2005 level? To increase the cumulative electric power installed capacity from non-fossil fuel based energy resources up to 40% by 2030. We have to reach the 40% non-fuel based energy. That means we move on into renewable energy at 2030. And also to create an additional carbon sink, 2.5 to 3 billion tons of CO2 equivalent through additional forest and tree cover by 2030. These are the agreement we have to take it at the Paris Agreement on 1st October 2015. So I will play the video to get some idea about that. Just a minute, I will play the video.
bright sunshine for around 300 days
Video is visible.
in a year.
That's cool.
Winds over most of the geographical area. Numerous powerful water streams in hilly regions and abundant greenery all over are increasing the demand of power day by day. Hence, India developed a strategy and roadmap to explore and exploit renewable sources of energy to power its dream of sustainable growth. A separate department of non-conventional energy sources was created in 1982, which was upgraded as an exclusive, dedicated and federal ministry in 1992, which was rechristened as Ministry of New and Renewable Energy in 2006. Recent resource assessments indicate India has over 1,000 gigawatt potential of renewable power from wind, solar, biomass and small hydropower. On the global platform of UN Climate Change Summit at Paris, India committed to reduce the emission intensity of GDP.
We have set ambitious targets. By 2030, we will reduce emissions by 33 to 35% of 2005 levels and produce 40% of our power from non-fossil fuels.
Government upscaled the target of renewable energy capacity to 175 gigawatt by 2000.
So we have to achieve the renewable energy 40% in the year 2030. So can you find it? What is the carbon dioxide emission in the year 2005 level? Anyone find it? Or you see the screen? Global climate change screen. Okay. So in 2005, see here, January 16, 2005 data. So our carbon dioxide emission is 378.21 ppm, parts per million. So now we are at here. This is data from August 16, 2030. So what is we are at carbon dioxide 414 4 p.m. 04 p.m. So we have to reach the 2030 at this level 378. So or less than 378. This is our main aim 2030. See, global temperature, when carbon dioxide increasing means global temperature also increasing day by day. See here, this is from 1884 to 2019. See here. So initially our earth is blue color. So see, so slightly the color is changing. Total blue color is changed. Now we are at 2020, but this data is available in 2019 only. See here, totally we are in dangerous zone. See here, dark blue indicates area cooler than average. Dark red indicates area warmer than average. We are crossing that average level. So we are in dangerous level. So that we are facing lot of issues. COVID also one of the problem because of this climate change. So come back to this one. So PPT is visible. Anyone please respond. PPT is visible.
Yes, madam, it is visible.
Okay, thank you. So we have to reduce the carbon dioxide at 2005 level at 2030. So this is small activity. So carbon, what is carbon footprint? So guess it. So dash is a measure of the impact your activities have on the amount of dash produced through the burning of fossil fuels and is expressed as a weight of CO2 emission produced in. Can you guess it? The first one represent the title itself have the answer. What is this? Okay, we will check the answer. So the carbon footprint is a measure of the impact your activities have on the amount of carbon dioxide produced through the burning of fossil fuel and is expressed as a weight of CO2 emission produced in tons. So 1 ton means 1000 kg. See here, this is the global carbon dioxide footprint. So orange color represents the India's carbon footprint. We are our contribution is 6.3 by 6.3 percentage. So in the atmosphere here, we have to mitigate this one. So what is footprint? So carbon footprint relates to the human activities and their impact on the level of greenhouse gases in the Earth atmosphere. And also, carbon footprint is defined by a measure of the total greenhouse gas emission caused directly and indirectly by a person, organization, or by product. So everything we do in our day-to-day life, from switching on a light or to driving a car and to using a product, all contribute to our individual carbon footprint, which in turn goes towards making collective footprint of the nation and the planet. So each individual make it as collective footprint, so automatically it will increase. So almost half of our carbon footprint we have to from electricity and 17% due to lighting. So we depend on electricity to meet several our daily requirements. So electricity can be produced by, already we know, from conventional sources and renewable sources. See, the carbon footprint of a household or person is directly correlated with the amount of electricity consumed and its source. Most of the electricity is produced by fossil fuel burning plant. See here, 1 kilowatt of electricity of household consume and released 1 kilowatt hour electricity we have to consume, but we have to release 830 gram of carbon dioxide equivalent in the atmospheric air. Okay, so this is the general power supply scenario, power supply generation scheme. So we are maximum of electricity depend upon the coal. So we have to generate electricity with the help of renewable energy. Only we have to mitigate the CO2 emissions. So what are the renewable energies? Today we are generating electricity with the help of this one. So these contribution is maximum. 70% we are producing electricity with the help of non-renewable sources, but renewable energy contribution is only 30%. But in the year 2030, our contribution is moved into 40%. So what are the renewable energy sources are there? Biomass, hydro, wind, solar, and geothermal. See here, so we get electricity from here, fossil, renewable, and nuclear energy. So this is the installed capacity in India as per August 31st, 2020. See, major power generation, we have to get it from coal, lignite, gas, and diesel. So hydro and diesel contribution is minimum. Total power generation in India is 372 megawatt. See here, renewable energy contribution and hydro also under renewable energy 1223. We are now under 35%. So we have to achieve 40% or more than 40%. Then only we have to mitigate the CO2 emission. See here, this is the sector-wise renewable energy. Renewable energy production is very minimum only. So we have to achieve that level. This is the renewable energy projection at the end 2027. Small hydro, we have to achieve minimum 180 gigawatt. Y-axis is in gigawatt. Biomass, we have to receive 160 to 170 in the year 2027. Solar, we have to achieve 160. Wind, nearly we have to reach 80 gigawatt. So is renewable energy is really alternative solution for carbon dioxide emission? Yes, true only, because fossil fuel is only available at up to 100 to 150 years. After that, definitely we move on into renewable energy sources. And also we have to eliminate the global warming. And also when we go for renewable energy, we have to maintain the sustainable power generation to power to all. This is carbon dioxide emissions. See here, compared to conventional sources, renewable energy plays major roles. Only minimum carbon dioxide. See, solar PV produced only 85 tons of carbon dioxide. So biomass only 45, nuclear only 28%, hydroelectric only 26, wind is 26. So this is one of the report collected from the Indian International Renewable Energy Agency. Renewable can reduce the CO2 emission by 70% by 2050. So as per report, only global carbon dioxide emission from the energy sector can be reduced by 70% by 2050 and completely can be washed out by 2060 with the net positive economic. Okay. The report also argued that increased deployment of renewable energy and energy efficiency G20 countries and globally can achieve the emission reduction need to keep global temperature rise to no more than 2 degrees Celsius. So avoiding the most severe impact of climate change. In 2015, 32 gigaton of energy related CO2 were emitted across the world. But when move on to 2050, the use of fossil fuel more significant decline, while oil demand will fall 45%. That means we are all move into the renewable energy. Okay, as per report, we have to achieve 70% emission in 2050. These are the data. So these are the power generation sources. What is the carbon dioxide emission per kilowatt? See, wind produced only 11 gram of carbon dioxide per kilowatt hour. Coal 980 gram of carbon dioxide. Natural gas is 465. Nuclear is 12. Solar is 14 to 45%. Hydro only 7. Ocean is 8. Geothermal is 11.3 to 47. Okay, so green shading represents, we move on into this power generation. Definitely we have to reduce the carbon dioxide emissions. So this is another one. These are the fuel. What is the carbon dioxide generation? See here, kerosene generate kilowatt, 1 kilowatt generate 0.267 kg carbon dioxide. Petrol 0.264. LPG 0.231 kilogram of carbon dioxide. Natural gas 0.206 and household waste 0.149. These are the vehicles produced. See here, diesel produced per liter, it produced 2.67 kilogram of carbon dioxide. These data I have to collected from this source. So petrol 2.28 kg carbon dioxide per liter, CNG produced 2 kilogram of carbon dioxide per liter, LPG produced 1.66 carbon dioxide per liter. So previous slide we see about per kilowatt. Here per liter, what is the emissions? This is the mode of transport. See, car per 100 kilometer it will produce 10.4 kg of carbon dioxide. By plane it produced 28.5 kg of carbon dioxide per 100 kilometer. By scooter 7.2. So train only we get minimum level compared to other mode of transport. When we go for bicycle means we have to avoid, we have totally the emission is 0. Or battery operated vehicle also reduce these emissions. So how do we have to reduce the carbon footprint? What are the best ways? See, the majority of electricity in the world by burning of fossil fuels such as coal. By lowering the amount of electricity, you see, automatically carbon footprint also reduced. With the development of long-lasting energy-efficient LED light lamps, installing LED bulbs as your primary source of illumination is one of the easiest way. Now, most of the domestic power, we go for these organization also, they go for LED lamp, but they used not direct DC supply, they are used adapter-based LEDs. Adapter takes huge losses. This is one of the drawback. When we go for direct DC, we have to reduce that losses. So next, LED light use 90% less energy than typical incandescent bulb, which will greatly decrease our primary footprint. As LED light also have a life expectancy that 20 times longer than traditional incandescent bulb. They will also help you reduce your secondary carbon footprint because you will only have to replace them only every 50,000 hours. So LED lifetime is maximum. So the lighting in a typical household constitute about 70% of its annual electric usage. So reducing its use and employing vastly more energy efficient light sources like LED will also have a significant benefit impact on our electricity bill. How do we have to achieve DC supply? Directly DC supply, we have to drive this load. Can you see it? Solar DC. So with the help of solar DC, we have to drive the DC load directly. No, we are not depending upon the adapters because adapter take the loss. See, in case power failure means some of the customer go for diesel generators, some middle and lower middle class go for inverters. When we go for these two equipments, we are facing carbon footprint increasing or decreasing. When we go for diesel generator and inverters, the carbon footprint is increasing or decreasing. All of you there? Automatically increasing. So we have to mitigate this one. So others with just without power, some people are there. So solar DC is the best solution for energy efficiency and reduce our carbon footprint. See, this is this conventional solar home lighting system. These data are I have to collected from IIT Madras. Professor Arjun Zungungwala developed this solar DC model. This is the conventional solar home lighting system. See, the solar produced the sunlight. So how to get the solar DC? With the solar panel, we get variable DC. With the help of charge control, we get the fixed DC. Again, our load is AC. With the help of this DC to AC converter, we converted into AC. Okay, this is the home lighting system. Again, in case directly we have to feed the load or we have to save it in the battery means again the AC supply is converted into DC because battery source only DC. Again, stored supplies we have to transfer into the load means again we have to use another more one of the converters DC to AC. So how many converters are we have to use here? 3 converters are used. See here, each converter takes 15% loss, and also solar with the battery takes 45% loss. While going to this technology, we feel more losses. So how to avoid this one? So Professor Zungungwala implement this uninterruptible direct current technology. We have to avoid this converter. Directly we go for DC. See here. So this is solar. We get variable DC. We have to convert it into fixed DC with the help of charge controller. This is our grid. So this is UDPM. That means uninterruptible direct current power model. So this model we have to feed both AC supply and DC supply. Home appliances we have to set. We have to fix the load, both AC load and DC load. So in case power failure means we go for DC load. See here, AC load. So with healthy conditions, direct AC supplies, the loads are running. If any fault occur means we have to store the DC supply from solar, store the energies well delivered to DC load. We have to run the load. No, we are not depending on the adapter. Directly we have to run the load. When going for this type of techniques, solar panel batteries directly to DC line, avoiding converter also, and also we have to reduce the carbon dioxide emissions. See the UDPM, that means the uninterruptible direct current power model detects these power failures at the condition automatically we have to DC drive the DC supply. These are the first UDC implementation UDC implemented in Government of Bihar, South Bihar or Discom, and IIT will equip 1 lakh home across Bihar with an additional power line that will carry uninterrupted DC power. So this UDPM consists of these buzzer production, BLDC, LED bulb, all are run direct DC supply along with remote to operate light and fan plus integrated DC socket come USB charger. These are the 48 DC supplies available in our India. So LED lamp, socket, DC powered TV, LED tube light, BLDC fan, cooler, remote control fan, mixer. So these are directly run with the help of DC supply. See here, this is the one of the comparative study. Compared to incandescent, fluorescent, CFL, LED. See here. So compare wattage level also minimum. When we go for this one, we get maximum illumination when we go for LED. So incandescent we get only 12 lumens per watt. Fluorescent, when we go for fluorescent, 63 lumens per watt. CFL compact fluorescent lamp means we get only 52. When we move on into LED means 88 lumens per watt. Lifespan also increasing when we go for LED lamp. So this is the DC driven light, fan and other motors are much more efficient than AC. Also electronic item like TV, laptop, cell phone, speaker, etc. work on DC to power them AC. We use adapter. Adapter also is huge. Already I explained it. So a direct DC line could reduce usage by as much as 50% and also reduce the emissions. These are the feature work. See here LED with incandescent lamp. When we go for LED, power consumption minimum compared to incandescent. So kilowatt of energy used per hour is only 0.006, but here incandescent used is 0.05 So both are operating same hours only. Then carbon dioxide emission. See here, carbon dioxide emission in terms of tons per year per lamp. Per lamp emit 0.152083 tons. But when we move on into LED, it will emit only 0.01825. Okay, so overall the carbon footprint reduction we have to achieve only in the LED 6.0225 tons we have to reduce when we move on into LED. So these are some of the mitigation scenario. How can we reduce our carbon footprint? So reduce, reuse, recycles. We have to reduce the plastic materials. So in case you have to use the container means again you have to use it. Recycles. If it is possible means you have to recycle the materials. So turn off and unplug all electrical appliances when not in use conditions. So walk, cycle, use public transport also. We have to reduce the carbon CO2 emissions. Take a shower instead of bath. So this is one of we have to reduce the carbon dioxide emissions. Reuse your shopping bags. Close the door to keep cooling in. When you use the AC means you have to close the door. So use of low energy light bulbs. Plant a tree. So we have to reduce maximum carbon dioxide emission with the help of only sampling trees. So only turn on the dishwasher, washing machine when it is full. So these are the breakdown of carbon dioxide within a home. Within a home, we have to reduce this usage. Lighting emit 12 percentage. Refrigerator 4 percentage. Washer and dryer 6 percentage. Electronic gadgets 4 percentage. Water heating 14 percentage. Others 12. Heating and cooling 48 percentage. By reducing the usage of home appliances, we have to reduce the carbon dioxide emissions very efficiently. So categories for carbon reduction opportunities are these are the categories of carbon reduction opportunity. Energy efficiency, being more energy efficient with electricity and natural gas. Next one, scope 3 reduction, that means reduce, reuse, recycle technology. We have to reduce the emission. Sustainable transport, that means go for renewable energy, EV based, electrical vehicle based transport. We have to reduce our emission. Local generation, so generating renewable energy locally through solar panels. Grid decarbonization means we have to feed our grid with the help of renewables. Today we are maximum percent we are using the fossil fuel based power supply. So we have to synchronize the panel with the renewable sources. We have to mitigate the CO2 emissions. Buying clean energy, that means renewable energy projects, big and solar wind farms only to mitigate these carbon dioxide emissions. These are the references. Thank you. Think future, go solar DC and reduce the CO2 emissions. Thank you.
Thank you, madam.
Thank
Thank
you.
you for the
accelerated, but in other parts of the economy, there are still steps to take. So just to sum up on net zero targets, then net zero targets, they're a relatively recent phenomenon, but they do reflect the scientific imperative to achieve significant emissions reduction as fast as possible, largely supported by the IPCC's 1.5 degree report. And the other thing that we found in talking about net zero emissions targets is that they're a great way to communicate to businesses, to civil society, to different citizens, that a really clear and simple way about what needs to be achieved for the energy system and for the broader economy. But to be effective, we need to be sure that these targets don't just remain targets, but they translate into real plans and ultimately turn that ambition into action for different countries and different regions and different cities around the world. So now I move on to the bulk of the presentation, which is how can these net zero targets be achieved? So to give a bit more background, I'll talk about which country and organizations have already put in place net zero targets, talk a bit about what the typical timelines for these targets might be, and then, as the first presentation also did, I'll discuss a few of the main measures and how they apply in the Indian context, and then more specifically, we can discuss the next steps for Puducherry and net zero. So there are currently relatively few countries with a net zero target. So there are a couple of countries who have already achieved net zero, although they have a very kind of special set of circumstances. So this is the island of Suriname and Bhutan. I think many of you might be familiar with the situation in Bhutan, where obviously they have very large forest areas and a relatively small population, and therefore the net carbon sink of their forest means that any emissions that their small population does produce is more than offset by their forestry sector. So I think although they have already achieved net zero, we can arguably say that they don't really apply to a country like India, which has a very large population, very densely populated, and has still got a huge amount of developing and growing to go. The next chunk of countries are slightly more applicable in that they are, often large industrialized economies, but they are also, relatively well developed. So Sweden, UK, France, Denmark, New Zealand, and Hungary. So many European countries, as well as New Zealand. These countries all have net zero targets in law. So these have been passed by their respective parliaments, and those parliaments will be held to account by climate change laws that they have passed. So if they don't put in place policies that do try to achieve net zero targets, and there are consequences for doing so. There are also a few big proposed legislations on the way. The major one to take note of is the European Union, which of course has 27 countries under the European Union, which are proposing legislation to achieve net zero by 2050. And recently, the Commissioner, Ursula von der Leyen, put in place legislation to achieve a 55% reduction by 2030, which puts the European Union on track to achieve the net zero by 2050. And we've got other countries like Spain, Chile, and Fiji as well, who also have legislation in the pipeline to achieve that. I think it's still worth saying that all of these countries are relatively well developed or have very high levels of cheap renewable resources. So Chile in particular has some of the cheapest solar prices in the world. And so it's arguable how applicable their situations can be to India. And then just very quickly, there are a few more countries who have net zero targets within policy documents. So these are published reports or stated policies by the governments, but do not currently have the legislation in place or are discussing legislation. So again, we can see many European countries and also other smaller island states and solar-rich countries like Costa Rica and the Marshall Islands who have them in place. So we can see here that momentum is definitely building around net zero targets. More and more countries are signing up. And it's a good way to mobilize different actors within the economy towards the same aim. So in summary then, we have two countries which have achieved net zero already, although these are kind of very special case countries. 6 countries with targets in law, which typically are on the 2050 timeframe. There's 3 countries plus the EU who are proposing legislation, and 12 countries currently with a policy document. As I said, net zero has become the new baseline for ambitious countries and regions and states around the world who are looking to achieve, ambitious climate change targets. And it's worth also noting that France launched the Carbon Neutrality Coalition back in September 2019 at the United Nations Climate Action Summit to try and accelerate these commitments. And they're kind of working with different cities and states and regions to develop plans for carbon neutrality. So outside national targets, there are also plenty of very important targets coming from cities, regions, and other organisations. So ahead of the COP26 conference, which is taking place in the UK next year in November, the UK government is very keen to try and build momentum ahead of this big event and try and get as many different cities or regions or businesses signed up to new net zero targets. And they're calling this the Race to Zero campaign, which is building momentum. So you can see here that 452 cities, 22 regions, over 1,000 businesses, 45 large investment houses, so these tend to be large hedge funds, and also 549 universities have all signed up to net zero targets. And although it's hard to gauge how big of an impact this will make, but these actors now cover 25% of global CO2 emissions and over 50% of GDP. So you can see that these net zero targets are really starting to gain momentum and really starting to cover a huge amount of the economic activity around the world. So now we move on to the important point, which is it's very well setting these targets for 20, 30 years time. And I think a lot of the skepticism has said, well, politicians are very happy to set a net zero target because they're only going to be in office for the next 4 or 5 years. They don't have to deal with the repercussions of the target, which may be 20 or 30 years out. So I think we really need to be careful about looking in detail about plans for achieving net zero and making sure that they stand up and they're reliable. So what I'll do through this section is just quickly talk through the different sectors in the economy and the main solutions for achieving net zero and how they might apply to Puducherry. So on electricity, I won't talk too long because I know my previous presenter covered this sector, and Mohammed from Terry, who's following me, will also be covering this in quite a bit of detail. But broadly, you can chunk this into 3 different areas of solutions. So the first is enhancing efficiency, and we know that India is also already doing really excellent work in this space in terms of air conditioners, home appliances, industry equipment, so that's maybe switching from diesel generators to electric motors, and then also LED lighting. The second big step is to try and shift away from fossil fuels. So there's been calls from people like the UN Secretary General about no new coal. It's quite difficult to achieve, but I think at least in the medium term, if not immediately, that would be possible. Adopting rooftop solar and then utility scale renewables, and then also batteries to help balance those variable renewable sources. And the good news is that all of these technologies are coming down in cost, and indeed building new utility scale renewables today can be cheaper than setting up a new coal-fired power plant. So it makes economic sense as well as environmental sense. And then lastly, it's about improving the system. So this is about building a national interconnected grid where Puducherry, for example, can benefit from having its supply balanced from different parts of India, with solar and wind coming in from different parts of the country when it's not being generated locally. And this will benefit from smart management, so potentially asking domestic or commercial users to turn their demand up or down at times of oversupply or undersupply, and then being rewarded for that. And this feeds into greater flexibility. And then obviously the most important thing in the near term is ensuring that now universal electrification has been achieved. The important thing is to make sure that electrification is 24/7 in its supply. So that electricity. On food, agriculture and land use, this often gets left out because people, the conversation often turns to the energy system, and people understand, transport and electricity very well. But one of the big sources of CO2 emissions is agriculture and land use. So we need to think of different ways to deal with this. So the first step is to address waste and diets. So having organic waste separation, at people's houses, which means that waste doesn't end up in landfills emitting methane, but gets separated and can be used in gasifiers to produce additional energy, for example, is really important. Less meat and dairy and local seasonal food. So I know, for having lived in India for a while now, I know that meat and dairy consumption is much less, and often consumption of local seasonal food is already the priority, or is already the go-to. So I think there's probably less area for improvement here, because there is already relatively sustainable diets in India versus other parts of the world. In terms of ecosystem protection, I know India already has a strong system of national parks, but then there might be an argument to expand these national park systems into additional areas to provide additional protection. Conservation area expansion to protect wildlife habitat and areas of forest cover, and then also to take steps to try and increase forest cover where possible. So that can mean recovering or reviving degraded land through plantation, or just increasing forest cover within existing wooded areas. And then finally, then there'll need to be a shift in agricultural practices. And we know already from Prime Minister Modi's statements over the past few weeks that he's very concerned about the efficient use of fertilizers within the agricultural sector. The agricultural sector themselves and the fertilizer production sectors are aware that there will need to be a rebalancing of fertilizer use to maybe move away from fertilizers such as urea and move towards some more sustainable fertilizers. There will also need to be reduced cattle farming, as bovine emissions from cows, etc., are pretty significant, and you can replace a lot of the nutrients required with plant-based diets. And then also there need to be increased crop rotation, moving away from monoculture crops, which causes extreme kind of soil degradation. And moving on to heavy industry, which is my area of research primarily. The first steps that can be taken is to enhance efficiency. And we know within India, under the Perform, Achieve and Trade scheme, that great steps have already been taken within key sectors such as iron and steel, cement, to adopt the latest energy efficient technologies. And this can include things like waste heat recovery, to make sure that any heat that would otherwise be vented or released into the atmosphere can be captured and recovered and put back into things like power generation on site or back into the process itself. The other area which is gaining traction at the moment, and where Terry has done quite a bit of work, is on the electrification of existing industrial processes. So this can be from very, very small things like diesel fans, which, diesel generators, which run things like fans in industrial units, can be replaced by grid electricity, which is steadily decarbonizing over time. Or it can move to larger processes such as electrification of iron and steel, where you shift from coal-based plants to electric arc furnaces, which help reduce emissions. Beyond just efficiency, it's also important to look at how materials are currently being used in the Indian economy. So India is already a relatively efficient economy in terms of its material use. So there's a lot of waste recycling that happens in the informal sector, for example. So there isn't a huge amount of gain to be had here. It's important, as India develops over time, that high level of efficiency is maintained. So, of course, this refers to reuse of waste materials and maximizing recycling, but also a look at kind of life cycle analysis of different products, and maybe whether or not you can substitute some some high polluting materials such as iron and steel or cement with some low polluting materials such as laminated timber or bamboo in construction sectors. And then lastly, a shift to low carbon fuels in those processes. So again, electrifying where possible, but also some of the work that we've been doing more recently is where you can use biomass, which is limited in supply, but still useful in certain sectors. And then more interestingly, hydrogen, which is a low carbon gas which can be burnt or used in a fuel cell to produce heat or electricity, which can be highly valuable in sectors such as iron and steel, petrochemicals and refining, and the fertilizer industry. In the transport sector, again, three big areas to look at are, first of all, modal shifts. So firstly, this is prioritizing cycling and walking. And in a densely populated state or union territory such as Puducherry, this is obviously very important. That the first means of transport can't be the car when there are so many people living in such a small area. You can fit much more people in your transport routes if people use bicycles or their feet to move around versus everyone sat in a car. But the next best thing, again, is affordable and accessible public mass transit. I'd also add to that, high quality public mass transit that people want to use. So I think in Delhi, for example, where the metro is very effective at taking people around, and it's a nice piece of infrastructure to use, it gets used a lot. Second of all, it try to enhance the efficiency of existing vehicles. So I noticed a comment in the message box about BS4 and BS6 standards. So that's a great way to make sure that moving straight from BS4 to BS6, as the government is planning, as a great way to ensure that vehicles being produced in India use the minimum amount of oil as possible, which first of all is very important in reducing emissions. But second of all is very important in reducing India's import bill. So around 80% of India's oil is imported mainly from the Middle East. So if you have a more efficient car, that's doing great things to reduce the amount that India is paying for foreign energy. And then lastly, as electric vehicles become more and more cost effective, you can start to electrify more and more segments within India. I think from the analysis that Terry's done, we've got a report coming out on this in November later this year. We already see in the 2- and 3-wheeler segments that electric vehicles make sense, they're cost effective. For the 4-wheeler segments, for taxis in particular, they will start to become cost effective versus combustion engines in the early 2020s. If you have a private vehicle, that might start to become cost effective in the mid 2020s. And then for things like heavy duty trucking, so larger vehicles, they might start to become cost effective around the late 2020s, 2030. So we can see with the cost reductions that we've seen in battery electric vehicles and the cost reductions we've seen in renewable electricity, we can really see that these will become competitive in the near future. And again, have a really positive impact in terms of shifting away from imported energy sources, mainly oil, to domestic energy sources, which is India's own renewable electricity. And then lastly, buildings. So again, enhancing energy efficiency is really important. Switching to air conditioners with the highest ratings and operating them at temperatures which are both good for your own health, around 24 degrees, and also good for your electricity bill. And then also is really important is that making sure that all new buildings that are going up today in India are built to good energy efficiency standards. And any buildings which we know are going to be lasting for the next 20, 30, 40 years, they're retrofitted to the highest possible standards to reduce energy bills. Again, we should be looking at electrifying end-use demands. So obviously lighting and heating, I guess heating is only really applicable in the northern states in India. But lighting in particular has largely been totally electrified. And people are switching, by their millions to LED lighting versus incandescent lighting bulbs, which is having a really significant impact. And then the final barrier to pass in terms of home or building energy use is cooking. And we know that the switch from fossil fuel cooking, so LPG or natural gas, to electric cooking will be challenging. This isn't just it's not just an issue of cost, but also an issue of whether or not you can cook your food in the same way that you used to. So things like cooking a roti on an electric hob is far more difficult versus a gas hob. So I think there are still barriers to electrifying cooking, but I think more work is needed there. And then lastly, within buildings, this is mainly related to appliances and air conditioners. Refrigerants need to be addressed. So this can be addressed through product standards, proper waste disposal, so moving from the informal sector to formal sector, which can be regulated and moderated. And then over time, replacing those high global warming potential refrigerants with low global warming potential refrigerants, as we've seen, has already been started in the air conditioning sector. So in summary then, applying these to Puducherry, as a densely populated state, a significant portion of Puducherry's emissions are coming from electricity generation, transport, and buildings. And with Puducherry, the city itself, being a generator of a large amount of the GDP through tourism and through its kind of urban and service setup, we know that these are going to be the prime areas of focus versus other states in India, such as Maharashtra or Haryana, where there are also large agricultural emissions. And the good news is that for electricity generation from buildings, we know that cost-effective measures already exist, which means that Puducherry could pursue a net zero target at zero additional cost versus a high emissions pathway. And actually, once you start to factor in things like reduced air pollution, reduced energy imports, growth in new industries, you would see a significant economic benefit to Puducherry for establishing a net zero target. And I think the other really important thing to remember is that setting a net zero target now can act as a really strong signal to investors, policymakers, and businesses that Puducherry as a state is really serious about emissions reduction, and that there is serious thinking that's gone in behind achieving net zero targets in different sectors of the economy. And the other good thing that, if Puducherry was serious about this, it can act as a nationwide and a region-wide pioneer for positive action on climate change, which can drastically improve the quality of life of its population. And we've seen in other parts of the world, in Europe or in the US, particularly in the US with California, where certain states or certain regions have acted as the pioneers and the front runners for action on climate change. They attract a lot of the talent in terms of people wanting to work in this area. They attract a lot of the finance in terms of investors looking to invest in the energy transition and in climate change reduction. And as so, can really start to achieve aggressive emissions reductions before other areas in the region. And I think that the final point to say is that the dichotomy that we previously thought about emissions reduction in terms of pitching the economy versus the environment is no longer really relevant for many of these solutions. So for someone to buy an electric two-wheeler will save them money, and it will also improve emissions. So this idea that you either have to pick economic growth or you have to pick the environment is no longer true. And in this way, Puducherry can be a champion of clean growth, which is achieving rapid economic growth in a clean way on its way to net zero. So I'll just wrap up with what the practical next steps can be for net zero. The other stuff, and this has only partly been achieved in the State Action Plan on Climate Change, which I've seen from Puducherry, is to understand the size of the problem. So this is really assessing the scale of both current but also projected emissions in each major sector of Puducherry's economy. Next is to try and consult on key solutions. So this doesn't just mean consulting with consultants or institutions like TERI, but it means also talking to businesses, investors, civil society, consumer groups, different religious organizations, different community organizations, all different types of organizations, to understand what do they see as the issues, what do they see as the benefits, etc. Off the back of that consultation, it'll be possible to formulate a detailed plan which sets out the intended actions and, more importantly, the timelines of such activity. And then, as we've seen around the world, try and establish legal and institutional backing, which means that the kind of commitments that are made by a state such as Puducherry aren't just a one-off commitment that is from one political cycle, will last with the test of time. Great, so thank you very much. I hope that was useful. And if you do have any further questions, then please feel free to contact me on the email ID below. Thank you very much.
Thank you, Mr. Paul. It was a well-structured and well-communicated presentation. And you have given your valuable inputs for achieving the net zero emission targets for Puducherry. Thank you so much. And as you said, we'll very soon have a broad consultation with all the stakeholders, as pointed out by you, for developing the action plan for the zero emissions for Puducherry as a part of the state climate change action plan revision. In fact, we should have this consultation process longer, but because of this current situation, we are not have a broad consultation. But we have been conducting a few consultations through web mode. We'll organize this one also, and we would welcome you also to be part of it as the technical consultant for our revision of SAPCC. Thank you so much for the wonderful presentation, Mr. Wilhall. Next, I would like to invite Mr. Mohammed Suwan Khan, who is currently a research associate at the Energy Research Institute and also the regional focal point for Asia Pacific of UN Sustainable Development Solutions Network, youth. He has spearheaded the solar PV assessment for different clients and has delivered techno-commercial feasibility of greater than 300 megawatts of solar photovoltaic projects. He is a renewable energy professional with a specialization in clean energy project development, financial modeling, and policy framework assessment, having an experience of more than 5 years. Welcome, Mr. Mohammed Suwan Khan, for your presentation.
Thank you. Thank you so much, sir, for having me here. I'll just quickly share my presentation. Sir, I hope my presentation is visible to everyone.
Yes, it is visible. Please go ahead.
Yeah, thank you. Thank you. So I would also like to thank my fellow presenters, Dr. Renuka, and my colleague, Mr. Will, for touching upon the points that I'll be covering up in my presentation. So they have already laid out the base of my presentation. So I'll try to focus on the benefits of going solar and the central financial assistance and the incentives that are provided by Government of India. So I'll quickly move on to the flow of the presentation. So this is the flow of the presentation in which I'll be covering up about the electricity scenario and how much percentage is there in total installed capacity of solar rooftop and ground mount projects. And after that, I'll be speaking about the benefits of rooftop solar system and what exactly it is, exactly a solar rooftop system. And since most of the participants are from distribution company here, so I'll also touch upon, I'll highlight the important points on why rooftop solar makes sense to distribution company and what are the central financial assistance and incentives that are provided by Government of India. And while winding up my presentation, I'll be discussing about different types of solar PV system that can be incorporated by different consumers. Yeah. So moving upon the electricity scenario of India, a lot of these points have been covered. So I'll try to just make a gist of points that were presented before me, and I'll try to conclude this within few points. So as we all are aware that India is the 4th largest consumer of electricity in the world after United States, China, and Russia. But however, the per capita electricity consumption is quite low as compared to other countries. So the global average is around 2600 kilowatt hour per person per year. So this is the global average. And for the financial year of 2018-19, the gross electricity consumption of India was around 1100 kilowatt hour per capita. So which is quite low as compared to other countries. And while China comes around 4400 kilowatt hour per person per year, and United States at 12,000. So these are the basic data and figures that represents that how per capita consumption is there in our country. And on an average, the annual consumption of electricity in India is around 1300 billion units. And for the financial year of 18-19, it was around 1360 or 1350. So on an average, we consume around 1300 billion units. And considering the emission factor from the coal, since we are consuming electricity having a majority of share from coal, so considering the emission factor from coal, which is around 0.98 tons of CO2 that we emit while generating 1 megawatt hour of electricity. So the amount of carbon emissions are quite high, and in general, it is estimated that for generating 1 unit of electricity, 1 pound of coal is required. So which is quite equivalent to 453 grams if we convert pound into grams. So considering the efficiency of our power plants, and considering the quality of coal that we have in India, so we have taken a rough figure of around 500 grams. So for generating 1 unit of electricity, we are consuming half a kg of coal. So now imagine the impact of burning 390 million tons of coal for generating almost 60% of 1300 billion units. Because the total annual consumption is around 1300 billion units, and out of which 60% is from thermal-based power plant. So consider that impact. So we are releasing 784 million tons of CO2 based upon the emission factors that are laid by Central Electricity Authority of India. And while I was going through the presentation of my fellow participants also, so they touch upon the GHG emissions. So there was a report by OECD which was floated in 2018, which talks about like 80% of GHG emission alone comes from energy, transport, water, and other infrastructure activities. And since my fellow participants also touched upon the Paris Agreement, in which we have agreed in our NDCs to decrease the emission and to participate in all the activities which will account to keeping the temperature below 1.5 degree Celsius pre-industrial levels. So there was another report in 2017 which IPCC floated. So they stated that there may be irreversible effect on climate change if global temperature exceeds 1.5 degrees Celsius over the pre-industrial levels. So this implies that unprecedented transformation will be required in our infrastructure, in our activities, in our day-to-day lives. And when I specifically talk about these transformation, and I try to link it with the energy sector. So renewable energy is the only thing which we can think upon. And these transformation, the scale of transformation that would be required, that cannot be taken individually by governments only. So we need to participate as a citizen, as a private capital mobilization with the help of public-private partnership to address this gap. So this was all about few numbers that I wanted to share with you. So there was a study that Terry conducted in 2018 and 19. So in which we found out that since in my previous presentation, I also shared that our total annual electricity consumption is around, average annual electricity consumption is around 1300 billion units. So in a study that we conducted, we found out that only 1300 square kilometers of land would be required if we want to set up solar power plant to meet our annual electricity demand. So out of the huge land that we have available within the territory of India, we just need 1300 square kilometers of land for installation of solar panel, and it can easily meet our electricity demand for the whole year. So this was a small study that Terry conducted in 2018. So moving on to my next slide, which talks about the tariff trend of solar. Because tariff is an important aspect when a consumer wants to switch from their normal grid to another source. So they definitely looks for tariff. So this is somehow similar to the prepaid or postpaid plan, telephone plan that you have. So this is somehow similar. And the graph that you are seeing right now, it is from 2018. So the figures have quite increased. And as you can see, the average industrial tariff for a consumer in different state is around 6.5 rupees. And it has eventually increased over the years. So these are the trend of tariff for an industrial consumer. And you can also see the domestic consumer with the last line that you can see. The last red line. So this trend also shows the domestic consumer tariff trend, and there is a black line which states that how solar tariff has been brought down by a lot of innovation in technology, in a lot of efforts that Government of India have taken over the years. So on an average, the tariff falls around 3.5 to 4 rupees per unit of electricity for a consumer who wants to that they have. So obviously going for solar is beneficial, and it is quite beneficial for building the gaps that we have in terms of fighting the climate change. So as you can see in this slide, so there is I've tried to give you a broad overview, like why solar photovoltaics will be quite successful in India. As you can see that India lies in the solar belt of the world, and there are three lines that you can see. So these are the Tropic of Cancer and Tropic of Capricorn, and since we all know that the revolution of Earth around the sun is somehow like that sun only is directly incident on these two lines, Tropic of Cancer and Tropic of Capricorn. So India falls in a region which is quite good for in terms of insolation, solar insolation, and it has a huge potential. And when we see the radiation graph of India specifically, so I'll show you the radiation graph of India in my next slide. So as you can see that we have a huge potential for solar power generation, and around 58% of the total land, which is around 1.89 million kilometers, receives annual global insolation above 5 kilowatt hour per meter square per day. So which is quite high in terms of radiation that is received in other parts of the world. And it is also observed that per capita electricity consumption is recorded to be highest in Western India, the western parts of India, as you can see in the graph, followed by the southern and northern regions. So most of the identified solar hotspots are also in these regions, and hence solar power generation could reduce transmission losses due to its decentralized distribution nature. So your solar power plant obviously can be installed within the place where your consumption, where your consuming electricity, so which will definitely reduce the transmission losses and other types of losses that may incur from conventional power plant generation of electricity. So yeah, so what is a solar rooftop system? Solar rooftop system is comprises of four major components, which contains a photovoltaic PV module. So these modules are mounted on iron mounting structures or aluminium structures, and that can be mounted very easily on roof or ground facing the south direction, keeping that India falls in the northern hemisphere. So if you're putting solar panels on a fixed tilt without moving them, so we can put them in the southern direction. And the second component is obviously the inverter, because the solar modules generate DC power, and you can convert DC into AC using the inverters, and that can be directly used within your household or within your offices or within your premises. And you can definitely use battery storage if you do not have access to the grid, and you can save it for later purpose. So this is the basic structure of solar rooftop system, which comprises of all these elements. So moving on to the benefits of rooftop solar, the first obvious reason is, when I talked about, was tariff. So when you're switching over from your conventional electricity to solar rooftop, you will be obviously paying less amount. So it reduces your electricity bill. So on an average, it is estimated that 40% reduction will be there in your electricity bill if you switch on from your conventional grid to solar power systems. And the second most important point is, like it was also covered during my fellow presenter's presentation, that there is no emission when we use these type of renewable energy sources. So there is no emissions and there is no noise in generation of electricity when compared to huge power plants that are run by thermal generation or other sources like diesel, gas. So there are certainly emissions, very higher emissions associated to conventional power generation. And one of the major aspect that I wanted to cover in this presentation is like how it is beneficial for distribution companies. So I'll get into this in detail in my next slides, but I'll touch upon here also. Like it also helps distribution companies to manage load and reduce outages, and can obviously provide jobs to the community. When a solar power plant will come into action, so it will definitely provide greener jobs, clean energy jobs to the people who want to work in that sector. And lastly, there is no maintenance for a solar power system. It only requires a minimal maintenance, like in terms of cleaning the modules on a weekly basis. And in terms of replacement, the total life of the system is around 25 years, and you just need to replace few components of inverter, because inverter life are in our studies that we have seen from the past, inverter life is around 10 years. And mostly there are now companies which are providing hybrid inverters and inverters which have several other features also, which can also be monitored using your mobile phone through an application. You can see how much electricity you are generating and how much trend was there within the month while you were using your solar power system. So there has been many technological advancement in terms of inverters also. So these are the basic benefits of rooftop solar. So moving on to this slide, in which I'll touch upon the points that why rooftop solar makes sense for distribution companies. So when we talk about the regulatory compliance, so distribution company, being an obligated entity, is entitled to meet the renewable purchase obligation by certain amount of renewables. So it provides an opportunity to distribution company that they can meet their RPOs, renewable purchase obligation, without having to purchase renewable energy certificates, which will be quite cheaper for them if they install solar power system, or if they create awareness within their region, within their premises, that they are supplying power, and consumers go on for putting solar power plant. So obviously their renewable purchase obligation will be met. So as you can see on the left side of the presentation, so these are the solar and non-solar RPO targets, which was made by Ministry of Power. And certainly these targets are not applicable to each and every state, because every state has Electricity Regulatory Commission, which governs these targets on an annual basis. But going by these provisions, you can see that by the year 21-22, there will be 21% of electricity that would be required from renewable sources as a purchase obligation to all the obligated entities, and out of which 10.5% will be from solar sources. So it provides an opportunity for a distribution company to meet their regulatory compliances. And when we talk about infrastructure, so the infrastructure benefit that rooftop solar can provide is in relation to addressing the technical issues like transmission and distribution, which contribute to DISCOM's financial losses. So these financial losses can be easily tackled by addressing small changes within the electricity generation. And since rooftop solar projects have minimal technical losses as per power generation, takes place near the location where electricity is consumed. So there are minimum technical losses within the system. It also helps in addressing the demand side issues, like when we combine the generation with the storage component. So that can also be used for demand side issues, for addressing the demand side issues. And when we talk about the customer satisfaction, so as we have seen that during the National Solar Mission, a target of 100 gigawatt of solar was set to be achieved by the year of 2022. So in order to support this, clean energy will not only resonate at the policy level, but it will also be at the forefront of the minds of energy consumers. So people are becoming more aware about the choices, about the things that they want to choose. They want to go more sustainable. I'll also give you an example. So there was a study which was conducted by Mercom Communications, and they interviewed around 1,700 residential, commercial, and industrial customers, and they found out that 45% of residential respondents, they thought that it was very important for India to develop and use solar power. So people are becoming more aware. So that is why customer satisfaction is also important. And lastly, there are direct financial benefits associated for adopting solar rooftop. I'll talk about all these points, like what are the central financial assistance that are provided by Government of India, and what are the incentives that are associated for distribution companies. So there are incentives also that are given by Government of India in their phase 2 guidelines. So moving on to my next slide. Yeah. So these grid connected rooftop solar program phase 2, it is also known as phase 2 guidelines in shorter version, which was floated by Ministry of New and Renewable Energy. So this central financial assistance was restructured to provide financial support to customers according to the capacity that they want to put in. So as you can see in the left side of the table, if a customer wants to install a system up to 3 kilowatt capacity, So 40% of central financial assistance will be provided by Government of India based on the benchmark cost. So what are the benchmark costs? So benchmark costs are differentiated based on whether jurisdiction counts as special category state like northeastern states and hilly states, and union territories of Andaman and Nicobar, Lakshadweep, Jammu and Kashmir. So these are the benchmark costs which are discovered by distribution company annually by floating a tender, and all the developers, they participate and provide their quote. So for example, for a system between 1 kilowatt to 10 kilowatt, the benchmark cost is around 54 rupees per watt peak. And it is around 59 rupees per watt peak for special category states. So as I already mentioned, that special category states are the states which are in northeastern parts of India and the hilly regions which lie in hilly region. So these are the benchmark costs. And so the financial assistance is also provided for consumers if they want to go beyond 3 kilowatt of capacity, and it can be provided till 10 kilowatt of capacity. So consumer can apply for central financial assistance, and that cost will be deducted from the final cost of this system. So it is somehow cheaper for a residential consumer to go for central financial assistance and take that subsidy in account. And for industrial consumer, there is no direct central financial assistance. But obviously, there are 2 points for industrial consumer for going towards solar rooftop. The first would be the tariff, because the industrial tariff is quite high as compared to solar rooftop tariff. And second would be the benefits, the tax benefits that an industrial consumer can avail using the accelerated depreciation method, and there are certain other tax benefits that they can showcase within their business. And under the phase 2 guidelines, so there was also DISCOM incentives that was restructured, and incentives was also provided to distribution companies. And the major highlight of this guideline was making distribution company the central agency, because DISCOM is an entity which interacts with the consumer. So they are in direct touch and they are in direct contact with the people who wants to put solar rooftop, and actually they are lending the services in terms of providing electricity to the consumer. So they have a greater outreach. So that is why distribution company was made the central agency under this phase 2 guidelines, and the incentive structure was also restructured. So there is incentive for distribution company if they install capacity above 10% up to 15% of the installed base capacity. So they will take into consideration the base installed capacity before the commencement of the year, and at the end of the year how much extra you have achieved. So you will be provided incentive. So these incentive, like you can see on the right side of the table, 5% of the applicable cost. So these applicable costs are based on the benchmark cost. So how much capacity they have put in within their region. So these are the assistance and incentives that were provided by the Government of India. So in this slide, I'll be talking about the types of solar PV systems and what kind of metering arrangement will be required for a consumer and how they can benefit from different types of metering arrangement. So there are basically 2 types of solar PV system. One is off-grid solar PV system, which is not connected to your grid, to your electricity grid. So in this special case, you would require storage, because since you will be generating electricity during the daytime, but for the night time, you would require some sort of storage to use that back. So that is why a storage element is included in these type of arrangements, which are known as off-grid solar, because they are not connected to your distribution grid. The second type is on-grid solar. So in this, your solar PV system is generating electricity, and you're also getting electricity from your grid. There is no storage component. So the excess electricity you can send back to the grid, and that excess generation can be settled in different terms. So I'll be discussing them in my next slides based on the metering arrangements that we have in different states. So the first metering arrangement for a consumer is net metering. So net metering is a utility billing mechanism which is available to most of the states, not all the states, but most of the states in India, that offers credit to customers who are making excess electricity through the rooftop solar or the solar power plant that they have within their premises and are sending back to the grid. So in this case, whatever excess you are generating, you will be sending back to the grid, and that will be accounted in these two ways. So there are two pictures that are showcased on this slide. On the left slide, you can see that your solar power system is generating 2 kilowatt, although your requirement is around 3 kilowatt. So you will be requiring 1 kilowatt from the grid. So you're not isolated from the grid. You will be requiring some power from grid. And utility will only bill you for the 1 kilowatt net consumption. They will not bill you for 3 kilowatt because you have already generated 2 kilowatt from your solar power. In the second case, as you can see, you are generating in excess. Your requirement is around 3 kilowatt, but you are generating 5 kilowatt. In this case, you will be sending back 2 kilowatt to the grid. So by definition, the 2 kilowatt that you are sending back to the grid, your utility will pay for that. But in most of the policies and regulations that we have in place in India, so these 2 kilowatt excess generation gets accounted to your account. So that is carried forward for your next month. So for example, for the next month, your consumption is again 3 kilowatt. So you will be subsidized this metering arrangement is consumer centric, and your utility, your distribution power company, they act as your battery bank. So whatever access you are generating, you will be sending back to your utility. The second type of metering is gross metering. So in this type of metering arrangement, whatever electricity you are generating by your solar rooftop system, it is exported to the grid, and all the electricity requirement for your consumption, you will be importing it from the grid. So you will not be consuming any electricity that you will be generating from your solar power system. You will be sending it directly to the grid, and your grid provider, your utility, your distribution company, they will be paying you on a fixed tariff, which is also known as feed-in tariff. They will be paying you. You will be selling electricity to your distribution company or utility. So I hope both the metering arrangements are quite understandable to each and every participant. So there is one other structure that most of the consumers opt for, and usually the industrial consumers opt for. So this talks about the third-party solar power PPA structure, in which a developer or a third party invest in the solar asset. So you won't be purchasing the solar power system directly. You will just be lending your roof or the area that you have within your premises to a solar power developer to put down a complete system. And whatever electricity will be generating from that system, you will be purchasing on a mutually agreed tariff. So most of the industrial consumers, they go for this type of arrangement where they have a very big factory or a warehouse, and they don't want to put their direct money, because they want that money to be utilized for their business operations, or for their ongoing operations. So this kind of model can be utilized by mostly by industrial consumers, but it can definitely be utilized by residential or societies where where the area is quite big and they are purchasing higher tariff electricity, and they can mutually agree on a tariff with the developer, and they can purchase that electricity on a cheap tariff. So these are the arrangements, different types of arrangements that we have for putting a solar power plant. So I'll also share a, a success story that we did for a steel and iron manufacturer in India. So it is one of the largest steel and iron manufacturer in India, with having premises, warehouses, manufacturing plants, stockyards in more than 20 cities in India. So we prepared a long-term renewable energy roadmap for this steel giant, and we identified around that 180 megawatt of solar PV systems can be incorporated within their campuses, because they have huge campuses, they have township, they have water bodies within their plant area, because for steel making process they require a lot of water, and mostly the steel plants are situated near the water bodies. So we also identified potential of floating solar power plants within their campus and dedicated entity, and also mostly the industries which are generating electricity using fossil fuels or other sources greater than 1 megawatt. They also comes under the obligated entity definition, and they have to procure some percentage of their electricity from renewables. And if they're not able to meet their RPO obligation, the renewable purchase obligation, so they have to purchase the credits in terms of certificates, which are known as renewable energy certificates. So we also provided them a study in which we showcase that it is feasible for them to going solar, putting up their own power plants within their premises, within their campus, within their mining areas, raw material location, rather purchasing the renewable energy certificates to meet these RPO obligations. So this study was also provided to them. And similarly for municipal bodies across India, we are also working with several other municipal bodies like Surat Municipal Corporation, Ahmedabad Municipal Corporations, by providing them strategic planning and research and consulting, and how they can incorporate these kind of solutions. And in 2017, for Solar Energy Corporation of India, we identified around 2,400 government buildings within India in different states that have a quite a good rooftop solar potential. And I guess from 2017 until now, more than 70 or 80% of the locations have been covered by different ministries, and they have already put in rooftop panels on their office premises. So that study was also provided by our team. So moving on to my last slide, in which I'll be talking about how we can plan a renewable energy roadmap. So this is applicable for municipal bodies, for nodal agencies, for industries, for corporates. So these are the basic steps which talks about we need to set some goals. We need to set some targets in front of us. Most of the companies are already reporting through their sustainability reports that they have few goals in terms of electricity consumption, and how they want to switch on to cleaner energy alternatives. So we need to have goes based upon our requirement and based upon our activities that we have around us and the electricity consumption that we have. And after that, baseline study needs to be done. Like we have to map resources that are easily available within a region. For example, there might be locations where biomass is easily available. The raw material for biomass is easily available, and there might be locations where wind energy is quite feasible depending upon the wind speeds that we have in different regions. So it comes around the baseline study, and after that we move on to techno-economic analysis, in which we do a feasibility study of different options of renewable energy, and we compare them in terms of finances and in terms of generation. That is it feasible within the region to go for solar rooftop or to go for different kind of renewable energy technology. And after that, business models are selected, that in which business model you want to go in. You want to put in your money and go for capex model, or you want to ask a developer to put in money within your premise and you will just purchase electricity. So that model is known as RESCO, Renewable Energy Service Company model, RESCO model. So apart from the business model, we also need to address the critical bottlenecks and risk, and what are the blind spots that may occur while putting a power plant within the premises, or what will happen in future. Since the overall lifetime of a normal solar rooftop power plant or a ground mounted solar power plant is around 25 years. So whenever a designing action is taking place, future aspects and future considerations, risk and bottlenecks are also considered. And obviously, once you have completed all these steps, you can roll out the final plan. You can come out with the power plants within your campus, within your premises, and you can showcase to the world that you are consuming that much percentage of electricity through cleaner sources, and you're avoiding thermal power generation. So that can be showcased within your final plan. I guess this is it from my side. If you have any questions, you can reach out to me here. Thank you so much for your time.
Thank you so much, Mr. Mitra. It was a very detailed presentation of our presentation, and I hope the audience will have been definitely benefited by your presentation. Now the forum is open to the audience for the various participants to place your questions or suggestions. Is there any questions from the audience?
Hello. Hello. A question, please. Audible?
Yes, proceed.
Mr. William, I have a question for you. I have two questions. The first one, I'll start with Mr. William. If you could hear me, may I ask you? Hello, sir. So
Yes,
you have mentioned, we discussed about countries that are having not just carbon neutrality, but also carbon negativity. Like you have mentioned countries like Bhutan and Suriname. There are also other countries like Kiribati, countries like that, Fiji, who are paying much more than what they are actually emitting. So the thing is, I'm reducing the global scenario to a national level. How is India in this state? Like, how is India taking up this internally? Like, is there a similar disparity, like a social justice issue, this climate changes? So is there a similar disparity among states of India? Like how we say this is among countries of the world. Are there similar disparities among states of India? And if so, where is Puducherry standing in this? Like in future, if not at least now, in future, is Puducherry going to pay more than what is going to emit, or it is going to remain in a good way?
Sure. Hey, thanks very much for that question. I think at the global level, you're right. There is obviously lots of conversations that take place, in particular at the Conference of Parties every year, the COP agreements, around the principle of common but differentiated responsibility. So this is about making sure that whilst we all do try to achieve significant emissions reduction, it's done in a fair and equitable way, appreciating that countries like the US, like the UK, like many of those in Europe, have emitted far more than countries like India, and as you say, far more than the small island Pacific states like Fiji and Suriname. I think that the way that that's approached at the international level is broadly, those countries who can pay more should pay more based on a kind of GDP per capita basis. And so, taking that approach, that there is a potential to apply that to India at the national level. So you could see states which are, have much higher levels of consumption. So, for example, in Maharashtra, particularly in, maybe larger cities like Mumbai and also in Delhi as well, if you have individuals who are consuming much more and spending far more income on goods, on travel, which result in far more emissions, then maybe more of the burden in terms of emission reduction can be placed on these wealthier parts of society, as opposed to trying to make everyone pay the same amount in terms of transitioning. So I think that's one point. And I think, one of the ways that you can go about doing this is, obviously through the existing tax and policy system, by ensuring that you have a very progressive tax system that makes sure that people at the bottom pay the least and people at the top pay the most. And then also, providing policy support or subsidies based on people's income and people's means, not just based on blanket acceptability. So I think those are a couple of ways. But I think also, as I mentioned in my presentation, for a lot of these technologies now that we're talking about for very aggressive emissions reduction, so obviously in the power sector with solar panels, in the transport sector with electric vehicles, it's very soon becoming the case, or it will become the case, it already has become the case, that these technologies don't cost any more. So people won't necessarily be paying more to reduce emissions. It's just going to be the default option. So I think where that is true, we should make sure people are aware of that. But as you say, where there might be some equity issues, it's really important to look how that can be rebalanced to make sure that the poorest don't suffer again.
Okay, sir. Thank you. This is fine. And I also have another question. This is to Mr. Shubhan Khan. Goes, we have commitments like we need to get to 40% of what renewable energy share in the entire consumption. So in that case, I would also compare Puducherry with that. Like Puducherry consumes roughly about 245 megawatts of power, of which the renewable energy share is only like 2 to 3%, which is very less. So is there a way to push this up, to pump this up, like a jump start, not like a few smaller steps, but like a hop, models that we can adapt from other states or other countries. Like Puducherry is a very small territory, so geographically it is very small. As far as solar goes, are there any other alternate renewable energy source that can increase the share of renewable energy in power consumption for this union territory of Puducherry?
Like you said, that India has a huge goal of reaching out the Paris Agreement that we have signed. And for reaching that, I think all the states and all the cities have to somehow participate on a parallel basis, and they need to create an environment in which renewable energy can be pushed in. So, like you said, for the Union Territory of Puducherry, uh, the total installed capacity, the total consumption is around 245 megawatt, and only 2 to 3% of comes from renewables. And I also mentioned that why it is important for the nodal agencies and the municipal bodies for our region to incorporate schemes, to incorporate things, for example, by creating awareness campaign within the city, so that consumers are aware of the choices that they have. They can go for solar power generation, they can go for other sources of electricity. So there needs to be some sort of revolution that should happen within our country. For example, I also touched upon, like, uh, in telecom industry. So there is a revolution that has happened. That is why we are getting 1.5 gigabytes of data every day. And as if you compare this to other countries, like in European countries or in UK, you don't get 2 GB of data every day. So it has only happened because there was a revolution that happened in the telecom industry, and there were other companies that came up with different plans, and people were aware of the choices, and they have choices that they can make, that they will switch on to some other telecom operator. And recently, Ministry of Power also came up with draft guidelines of choosing power. So in future, you will also see that the consumer will get an option to choose the power. They can choose the distribution company also. Our Prime Minister is talking about one sun, one grid. So it has a larger implication, and it has a larger objective of reaching out to the people. So in future, you will definitely see these kind of revolution which will happen within the electricity Ministry of New and Renewable Energy. Distribution company was made the nodal agency because they interact with the consumers on a regular basis. So that change can only happen when we create awareness amongst the consumer, when we tell them what is right for you. And I hope we 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 should see that change within a couple of years. Yeah, thank you.
Yes, sir. Fine. Fine. Thank you, sir.
Will, sir, one question to Mr. Will. Is there a difference between carbon neutrality and net zero emission?
No, they typically mean the same thing. So they are the same. Yeah.
Any more questions from the participants? If there's no more question, then I think we have come to the end of the session. Can we go ahead? Well, first of all, I'd like to thank Dr. G. Renuka Devi, Mr. Bill Hall, and Mr. Mohammed Siddharth Khan for immediately accepting to participate in this webinar as a resource person and give valuable information on the subject to the participants. It was wonderful experience listening to your presentations. I would like to thank our secretary, become director, Smita Meron, for being continuous support and motivator in organizing these webinars. And also to my senior scientific officer, Dr. Chandra, for the support in organizing this webinar. And